Math lesson number 26, Integral Exponents. Let's start with zero power. For any non-zero real number n raised to 0 is always equal to 1. For example, 30 raised to 0 is equal to 1. 30 is not 0. That's why the answer is 1. Number 2, negative 12 quantity raised to 0 is equal to 1. Negative 12, the whole thing, is not 0. That's why the answer is 1. For number 3, negative is not included in raising to 0. So negative 35 raised to 0 is equal to negative quantity 35 raised to 0. 35 raised to 0 is equal to 1. And then plug in negative. The answer is negative 1. A raised to 0 is equal to 1 if and only if A is not equal to 0. Number 5, 6x raised to 0 is the same as 6 times quantity x raised to 0. Quantity x raised to 0 is equal to 1. 6 times 1 is equal to 6, given that x is not equal to 0. Number 6, the whole 2h is included in raising to 0. So 2h raised to 0 is equal to 1, given that h is not equal to 0. Now what if the base is equal to 0? 0 raised to 0 is indeterminate. So the answer is indeterminate if the base is 0 and the exponent is 0. That's why we do not allow the base to be 0. So let's have negative power or negative exponents. For any non-zero real number x and any positive integer n, x raised to negative n is equal to 1 over x raised to n. So as you can see, the negative n, the negative power, becomes positive, but it is placed in the denominator. So let's have example. 4 raised to negative 2 is equal to 1 over 4 squared. So as you can see, the negative 2 becomes positive 2, and 4 raised to negative 2 is transferred or placed in the denominator. So 1 over 4 squared, 4 squared is 16, so the final answer is 1 over 16. Let's have number 2, 1/3 raised to negative 2. So the whole thing will be transferred to the denominator, and the negative exponent will turn into positive. So it will be 1 over 1/3 squared. We know that 1/3 squared is 1 over 9. And 1 over 1 over 9 is equal to 9. Or the reciprocal of 1 over 9 is 9. So that's number 2. Number 3, 2 raised to negative 3. So that will be 1 over 2 cubed. As you can see, 2 raised to negative 3 is placed in the denominator, and the negative exponent is changed to positive. So 1 over 2 raised to 3. 2 raised to 3 is equal to 8. Because 2 times 2 times 2 is 8. So the final answer is 1 over 8. For number 4, x raised to negative 3 is equal to 1 over x cubed. So the whole thing is placed in the denominator, and the negative exponent becomes positive. So it will be 1 over x cubed. For x must not be equal to 0. Why? Because we do not allow a 0 denominator. It will be undefined. So x must not be equal to 0. For number 5, x raised to negative 5 is in the denominator. So let's have 1 over x raised to negative 5. It will be 1 over x raised to 5. So x raised to negative 5 is 1 over x raised to 5. And dividing that, we have 1 over 1 over x raised to 5 is equal to x raised to 5. So the reciprocal of this is this. So that's it for the examples. Next, let's have power of quotient. For any non-zero numbers x and y, and any positive integers a and b, x raised to negative a divided by y raised to negative b is equal to y raised to b over x raised to a. So as you can see, x, this is negative, is transferred to the denominator. The negative denominator, exponent, will be transferred to the numerator so that the exponents will become positive. Okay? And another example, x over y raised to negative a. So the whole thing, x over y, will be, or will change to its reciprocal, y over x, and the exponent will become positive. So that will be y raised to a, and then x raised to a, x raised to a. So x over y quantity raised to negative a is equal to 1 raised to a over x raised to a. So take note of this format. Let's have example number 1. F over b quantity raised to negative 2. So this one, we will use this pattern to simplify this. So we have f over b raised to negative 2 is equal to the reciprocal of f over b, b over f, and then the negative 2 will be changed to positive. Distribute the exponent, b squared, f raised to 2, f squared. So that's the simplified form. Number 2, 3/4 quantity raised to negative 3. So again, the reciprocal of 3/4 is 4/3. The negative 3 will be changed to positive. And then distribute 4 raised to 3. That's it. 3 raised to 3 is 3 raised to 3. 4 raised to 3 is 64 because that's 4 times 4 times 4. 3 cubed is 27. So that's the simplified form. Now let's have equal powers. Two powers are equal if and only if they have equal bases and equal exponents. So in symbols, x raised to a is equal to y raised to b if and only if x is equal to y and a is equal to b. So as you can see, the bases are the same and the exponents are the same. Now this concept is used to solve for the equations that involve exponents. So let's have example. 3 raised to x is equal to 81. We know that 81 is 3 raised to 4. So let's cancel the bases and let's focus on the exponents. X is equal to 4. So the exponents must be equal also. So in equation number 1, 3 raised to x is equal to 81, x is equal to 4. So let's have number 2. Our goal here is for the bases to be the same. So let's have, and for the exponents also to be the same. So let's have number 2, x cubed is equal to 8. X cubed is equal to 2 cubed. We know that 8 is 2 cubed. So we will cancel the exponents, 3 and 3, and we'll focus on the bases. X is equal to 2. The bases are the same, the exponents are the same. So in example number 2, x cubed is equal to 8, x is equal to 2. Let's have number 3. 4 raised to x is equal to 128. 4 raised to x can be turned into 2 squared raised to x. And 128 is equal to 2 raised to 7. Now, as you can see, the bases are the same, 2 and 2. And we will simplify this, 2 raised to 2x, because 2 times x is 2x. And we will focus on the exponents because the bases are already the same, 2 and 2. So getting the exponents, we have 2x is equal to 7. That's it. Dividing both sides by 2, we will get x is equal to 7 over 2. So meaning to say, in the equation 4 raised to x is equal to 128, x there is equal to 7 over